Alright, hi guys, it's Kelly here. It's May 1st. This is the last video project I'll be doing for you guys and want to go out with a bang, so to speak. So I created this triangle right here, triangle KAJ, my initials, you're welcome. What we're given here, we know that this angle, angle A, is 45 degrees. We know the coordinates for A and J. We don't know the side lengths of KJ or KA though. So we're going to have to probably use SOHCAHTOA to find it. Yay. Basically what our question is here, use the given information to find three trigonometric functions from angle K. So once we find the side length of x and y, we can use angle K as like our reference angle to find these three trigonometric functions. Alright, so where to begin this problem? Well, I'm given angle A is 9, 2, and J right here is 3, 10. Well, in order for me to even use SOHCAHTOA, or sine opposite over hypotenuse, cosine adjacent over hypotenuse, or tangent opposite over adjacent, I'm going to need at least one side length to work off of. So with that in mind, I'm going to find the distance from AJ and find that. So let's start right here. If I can find a marker that actually works. 1 second. Alright, so distance. We're going to find the distance of segment AJ then from this triangle. So with that in mind, there are a few ways you can write a distance formula. The big stereotypical way is y sub 2 minus y sub 1 squared plus x sub 2 minus x sub 1 quantity squared. We're going to be using this formula. So I can plug in those points now then. It doesn't matter if you say that this is x sub 2 or x sub 1, or say that 3 is x sub 2 and say that 9 is x sub 1. It doesn't matter. We just have to make sure that we use the same coordinate. So for my y sub 2, I'm going to say that's my 2 from A. So 2 minus y sub 1, or 10. Plus x sub 2, that'll be my 9 then. Minus x sub 1, or 3. So let's find this distance then. I'm going to relabel this as segment AJ. So let's simplify it under this radical now. So 2 minus 10 is negative 8. We'll square that. And then 9 minus 3 is 6. We'll square that as well. So negative 8 squared is the same thing as positive 8 squared. We get 64. And then 6 squared is going to be 36. We go up here. 64 plus 36 is 100. The square root of 100 is equal to 10. So this gets me 10 units. So right here, for my JA, we found that to be 10 units. Alright. So now that we've found that, we can now use SOHCAHTOA to find the side length of KJ and KA. Now, some of you might be a little ahead of the game. If you notice here, this is 45 degrees. This is a right triangle, obviously. But if we take 180 minus 90 minus 45 to find this angle, we would find that this angle is also 45 degrees. And there are a lot of really cool special properties with 45, 45, 90 triangles. Not sure if you guys have learned that yet, but I'm just going to show you the long way that you would normally solve a triangle. So we're with that. Okay. So let's use SOHCAHTOA to find, let's just find x first. So the trigonometric function I'm going to use, well, starting from here, this would be opposite and this would be adjacent, right? This is my hypotenuse y because it's the longer side. So from angle A, I could use K, it doesn't matter. I'm just going to use A for right now. To find x, I could say that the tangent of 45 is equal to opposite over adjacent, or x over 10. So let's do that here. So tangent of 45 is equal to x over 10. I tell you, these markers get worse every single time I use them. Okay. Now I want to isolate my x, right? So let's multiply both sides by 10 to get this out of the denominator. So I get 10 tangent of 45 is equal to x. Let's use our calculator. Type in 10 tangent of 45. Look at that, I get 10, special property. So x is equal to 10 units. Alright, so we just found the side length of kj, then that's also going to be 10. Alright, so now that we know this, we could use, because this is a right triangle, and all these, this side and that side, kj and aj, they're both solid numbers, they're not decimals. So if we wanted to, we could use Pythagorean theorem, or if we wanted to, we could also use more SOHCAHTOA. I'll show both ways in case you guys want to know. So I'm going to do SOHCAHTOA first. I want to see which of these three options could I do to find y. Would it be adjacent over hypotenuse, opposite over hypotenuse? It doesn't matter which one we use. We just use tangent. I feel like a lot of people always use sine, so I'm just going to use cosine. Cosine from 45 degrees right here would be adjacent over hypotenuse, so I'm going to write that. So cosine of 45 is equal to adjacent, so 10, over my hypotenuse, or y. Now my y is in the denominator this time, we can't have that. So kind of like we did up here, we're going to multiply both sides of the equation by y. So that cancels. This means over here I get y cosine of 45 is equal to 10. I'm going to divide both signs by cosine of 45 to isolate my y. So let's get our calculators out. So 10, gotta make sure I'm in the right mode. There we go. Okay, 10 divided by cosine 45. I get this strange, ugly decimal, 14.14. We'll find the exact answer with Pythagorean theorem next, so don't worry. Okay. So this is our length for y, 14.14. We don't like decimal answers, so we want to get exact. So I'm going to do Pythagorean instead, and I should get the same answer, but it'll show you both ways of doing it. So I'm going to go over here now. Why don't we change it up? Let's use green this time. Feel fancy. Okay, so Pythagorean theorem. That's leg squared plus leg squared is equal to hypotenuse squared, right? We're assuming that we still don't know y, and then we just found it. So leg squared plus leg squared, that's going to get me 10 squared plus 10 squared is equal to y squared. Leg squared plus leg squared is equal to hypotenuse squared. 10 squared is 100 plus 100 is equal to y squared. Add these together, we get 200. So to solve for this now, we have to take the square root of both sides. So square root, square root. Square root 200, that can totally be broken down. I'm going to rewrite down here. We want to get perfect squares out of this radical, so it's more simplified. So, I mean, easiest thing to say would be 100 times 2 is equal to y, because the square root cancels the y squared. Square root of 100 is 10, so bring the 10 out. So my simplified and clean version of 14.14 will be 10 root 2. So these two, if we plug it into our calculator, the 14.14, yep, same thing. You guys can't see it. It's the same, 10 root 2 is the same thing as 14.14, except this is an exact answer. So now that we know the length of all three sides then, we can erase our y. This is 10 root 2. We can now find the three trigonometric functions from an angle k then. I'm just going to put a little dot right here so I know where I'm working from. I'll do this over here. Let's use blue again. Alright, so I'm going to start with sine. Clear this off. Alright, so this will be our final answer then, because we just are, we want to use the information. We found the length of these, all three sides. Now we just have to use SOHCAHTOA again. So from angle K, sine, right here, make that bigger. Sine, here, this is opposite. This side will be adjacent then. And right here, my longest side will be my hypotenuse. So let's just label that. Alright, so sine, or the SO in SOHCAHTOA, is always opposite over hypotenuse. So that's going to be 10 over 10 root 2. Alright, so if you notice here, these 10s, they both cancel. So I can cancel it out. However, we cannot have a square root in the denominator. So 1 over root 2. To get rid of this root 2 in the denominator, I want to multiply the numerator and denominator by root 2. Let's do that. So root 2 times root 2 is the square root of 4 or 2. So my sine then will be root 2 all over 2. For cosine now, it's going to do the same thing. I'm going to take my adjacent over my hypotenuse. So once again, 10 over 10 root 2. Our 10s cancel, and once again, we cannot have a square in the denominator, so multiply the numerator and denominator by root 2. So my cosine, just like my sine with the same answer, will get me root 2 over 2. Alright, last thing to do, the last trigonometric function, is going to be our TOA, or tangent. So from K, that's going to be opposite over adjacent, so 10 over 10. It's going to simplify really nicely. So 10 over 10, these both cancel, so really my tangent will be 1. Cancels, so tangent is equal to 1. Alright, so brief recap. When we were given this problem, we knew the coordinates of A and J, so we used distance formula to find this. After that, we used tangent to find the measure of x right here. We found that to be 10 as well. Then after that, we used cosine to find the length of our hypotenuse. After that, we just used SOHCAHTOA to find our 3 trigonometric functions. So yeah, last math video. Hope you guys enjoyed it. If you have any questions, just see me in class. So thank you for watching, and bye.